Never before has a man-made object come so close to the Sun. The Parker Solar Probe will give us unique information about our star. But despite all the excitement about this project, people are curious about one thing. Why doesn't the probe melt when it's close to the Sun? The Parker Solar Probe sometimes stays in the hottest part of the Sun, which is not the surface. The corona is the hottest part of the Sun. We need to learn more about our Sun, because without it, there would be no life on Earth. Solar radiation also affects our environment and the times of year. The Sun's activity also affects our planet's magnetic field all the time. And some people say that solar storms make people feel as confused as when the moon is full. Astrologers and cosmologists are especially interested in finding out more about what goes on the surface of the Sun and in the corona, which they didn't know much about before. This thin glow around the Sun is called a corona, and it can only be seen from Earth with special glasses or during a solar eclipse. Scientists still don't know much about the corona, even though it is several kilometers above the Sun's surface and has temperatures of up to 1 million degrees Celsius, while the Sun's surface is only about 6,000 degrees Celsius. The Sun is not heated the same way all over its surface, just like its atmosphere. Constantly things join, bubbles form, and forces swirl around it. The corona is the same, but the heat is in the form of clouds of the smallest particles. The things going on at the Sun's surface have a direct effect on the clouds or vapors. The burning processes on the Sun create or at least affect the particles that make up the corona. We don't know exactly how these interactions work yet, and one of the Parker Solar Probe's jobs is to find out more about them. The extreme heat in the Sun's environment must be caused by physical forces, and probably also chemical processes that we don't know about yet. We might even be able to use what the probe finds to improve our own energy industry. Just think about how electricity from a wall socket is always made by generating heat. If we could do the same thing, we might be able to make more energy much more easily or multiply energy in a simple and maybe more environmentally friendly way. The probe also measures these well-known forms. These are huge particle explosions. The strong explosions on the surface of the Sun are what cause the winds. During these events, plasma and particle streams are sent out. At first, the streams move around close to the Sun. At some point, the charges reach the corona and are freed from the Sun's gravity by a process that is also mostly unknown. If these particle streams hit the Sun's magnetic field, they move away from the Sun at high speeds and into space. Solar flares and winds have been studied in depth for less than a century, which is long enough to find patterns in how they happen. The Sun has a regular cycle of 11 years, and eruptions happen in predictable ways during that time. The winds were almost always the same for a while. But then the Sun's behavior changed. Scientists were worried at first because the activity decreased in a strange way, but then it picked up again. These things happened in a way that had never happened before on Earth. We can't be sure that the Sun sometimes has strong winds and acts in strange ways, because this could be dangerous for our worm, which is getting more and more advanced. The ESA and many other countries will send the probe into space. NASA took advantage of a time when the Sun and Earth were close together, and the probe's path was perfect because probes couldn't go straight to their destinations but had to move along the gravitational fields of planets and finally use their force for onboard flight. Before heading towards the Sun, the Parker Solar Probe did 7 laps around the baby. NASA also used these flybys of Venus to learn more about the planet itself. In April 2021, the probe flew through the Sun's bright, hot corona for the first time. And now you can find out how it did it. Even though it was 2,500 degrees outside, the sensitive measuring tools inside the probe stayed at just over 30 degrees. The probe got as close to 6.1 clear kilometers to the Sun's surface. Teams of scientists, engineers, and workers from all over the world worked on this masterpiece for almost a decade. The success of the probe depends on a high-tech thermal protection system that uses special materials to shield the probe from heat and a cooling system that uses water. The water cooling system was made by the Hopkins Applied Physics Lab in Maryland in the United States. The thermal protection system is made of 2 layers of carbon fiber reinforced carbon, which keeps its shape even at high temperatures. In between these layers is a carbon foam. There are so many air holes and fibers that almost no heat gets to the outside. The Parker Solar Probe is fully covered in white aluminum oxide. The color and material reflect light in the best way, so the outer covering reflects more heat than it absorbs. In between the carbon and the aluminum oxide is a layer of tungsten, which is almost white and very dense. Due to the separating layer of tungsten, the outside skin and the carpet layers inside the probe can't really combine with each other. So the heat stays on the outside even in the Sun's corona, which is very hot. The probe's position and path are set up so that the shield is always facing the surface of the Sun. This way, the Parker Solar Probe can still look directly at the Sun. Measurement sensors have been put so that they just barely peek out from behind the shield, which protects the way into the outer corona. Even on future trips, the Parker Solar Probe will only fly through the Sun's outer layers, and only for a very short time. The probe only touches a small number of hot particles, so only a small amount of heat will be transferred. You can think of the probe's flight through the extras as reaching into a hot oven. As long as you don't touch the hot metals or food, you won't get hurt, even if you only put your hand in the oven for a short time. Even though the Parker Solar Probe was well prepared, the fly-through times were made to match the short amount of time it spent in the oven. Scientists and engineers working on the first pass held their breath, but when the Parker probe worked perfectly on April 28, 2021, even though temperatures were close to 3,000 degrees, NASA and all the other places involved were happy. The probe briefly raced through the corona at a speed of 586,000 kilometers per hour, took initial measurements, filmed the stream of particles, and then left after only a few hours. When the probe is far from the Sun, it sometimes comes close to Venus or Mercury. Scientists would like to use these times to learn more about these 2 planets because they are closest to the Sun. The probe will probably get the closest to the Sun on December 24, 2024 of all days. For the scientists, it will then really feel like Christmas, and they can wait a year for the special measurements. At the moment, there are plans for 5 approaches. The last one will happen in July of 2025. Everyone on Earth hopes that the design of the probe will hold up through all of its flybys. But scientists and workers don't think the probe will work for much longer than the summer of 2025. If the Parker probe is still working when it's supposed to finish its job, the mission can be extended at any time. The probe was named after the U.S. scientist Eugene Parker, who came up with the term solar wind, and is still seen as a pioneer in the field of solar research. Here at Simple Space, we'll make sure to keep you up to date, and we're excited to tell you soon about the most important news in solar exploration. Do you think it's cool what technology can do, or do you just take it for granted? We'd like to hear your feedback and thoughts about exploring the Sun and the Parker probe. And please don't forget to make sure that you have subscribed.